Hi everybody, my name is Morgan Bickle. I'm the CTO and co-founder of Kinvey. And Kinvey is a backend as a service for mobile application development. And I'll get into a little bit about what that is. But basically, I just wanted to really, for this meetup, I was thinking it would be kind of fun to build an application. So a lot of folks on our team, we were always joking around. It'd be really cool if there were actually a taco copter instead of a taco truck. It would just be way better than just a truck. So we were thinking maybe building a POS application. But you know, I have not very much time on my hands. How many parents do we have in the room? And newborns? Anybody? I have a 10-week-old. Dan also has a very young child, I know. So I don't really have a lot of time, and I thought maybe a better application would be to build a to-do list. And so I want to show you guys a demo, basically. So as I said before, Kinvey is a backend as a service. We use NoSQL, and we thought it was a really good fit for our application data service. So mobile application development is drowning in data right now. There's lots and lots of different kinds of data that you can capture. Everyone's familiar with the general use cases: video, photos, music, application data, GPS locations. It's just plethora of information out there. Tweets, sometimes the data itself is less important than actually sharing the data. User profile information. So developers just want to be able to store information on the users, collect analytics, and do all of these things. So data is a huge problem, and NoSQL really does help make things a little easier. But then there's a question of time. So everybody's here is pretty much familiar with lack of time, I'm sure, because there are a lot of developers and there's so many things to learn, so many tools. It's pretty overwhelming. So if you want to actually scale a NoSQL database, you have to do many things, as the first presentation demonstrated. When indexes outgrow your memory, you have issues. Data doesn't fit into memory. There are lots of problems that arise when you're trying to manage a backend infrastructure, and NoSQL doesn't necessarily answer all the questions of scaling your data. You still need to have somebody who is really an expert. So NoSQL is difficult. It can be difficult. It's easy to get up and running and started. And then there's the other thing is, as a mobile developer, it's like you have all this fragmentation, right? There's tons of different devices, there's different platforms. So it's like, how do you deal with all of this stuff? And then you're probably going to have to build a REST API on top of whatever database it is that you pick, right? So we have backend as a service. Advantages of backend as a service are that you don't have to deal with building REST API yourself. You don't have to deal with scaling and sharding and all of that other things. So what we did was we picked NoSQL because we felt it had some really nice advantages for our data services. And the advantages were a schemaless data storage. And basically what that means is that you can store documents in collections, and each document doesn't have to match an existing type. It can be a heterogeneous collection of documents. So let me show you guys a real-world example. So we built, in a day, we built this to-do list on Kinvey. Let me pull that up. And as you can see, my to-do list has some categories. It has a honey-do list. And inside the honey-do list, as I click, and it doesn't do anything. Okay, Android emulator is pretty lame. You can see I've got a list of items in here, and within the items, I can store different attributes, right? So that's all great, but you know, when you have to deploy a new version of your application, what do you do with the different attributes that you want to add? And what do you do with the old versions that are out there? So you have existing users. Everybody's familiar with this problem, right? If you've ever dealt with a SQL database, you know it's a hassle. So I'm going to drop back to the Kinvey console here, and you can see that there's two collections in this application. There's a list collection and a list item collection, and you can see the data in there from version 1. So what I'm going to do is kickstart version 2. And while that emulator is starting up there, I'm going to tell you what I changed here in version 2. So on the client app, all I did was I wanted the ability to track priority on each item. And so my data collection, before was supporting the original version without a priority attribute. The new version actually has a priority attribute on it. So the only thing I really needed to change was my UI and the data that supports the UI. And as the emulators they're loading, I'll drop back to the data browser here. So you can see in the data browser, we have the ability to see the original data that was within that collection. This particular collection and data inside only has 4 attributes. These are default attributes that get assigned. So here's the new version of my app. I'm going to go in, I'm going to click on an old version of the data, and you can see the application now has the ability to save. Actually, let me flip back. I'll create a new item. So I'm going to create a new item. Pick up. So it'll happily save the new item in my collection. I'm dropping back to the console now, and I'm going to hit refresh on the data browser. So it's important to note here that this data browser is using exactly the same REST interface that the native libraries for Android and iOS are using. And so, if you think about it, what we have here is 3 versions of different applications, 3 clients interacting with the same collection, and they're all behaving without me having to change anything about those clients. I'm not having to run shell scripts or anything like that. And so I can actually go in and click on the old item, go back to the version 1. You'll see that it brings into the list the new item and displays it. Okay. And then the last thing I want to demonstrate here is we've built security on top of the collection. So we have our own security model, and we basically make sure that different devices cannot write to the same collection by default. So all devices can view this data by default, but they can't all write to the same data. So if I go in to this object, which was created by the original version, and it's also on a different device, and try and save it, it's going to fail, because this device right here actually, even though I don't have different users, I'm not tracking user profile or anything like that. What's happening is the libraries are managing the permissions between devices. And so I actually want these devices to be able to write to the entire collection. So I'm going to go into my collection settings and change it to write. Flip back. And I should now be able to save that data. So basically, in conclusion, what I want to say is that, you know, we felt that the schemaless function within NoSQL was really powerful, and it was good for us to base our data service on it. Yeah, so that's all I got. Any questions?
Wait, what database do you use?
We use MongoDB.
I think your schema really, even though you say you have no schema, but there are actually there are schemas. One is list, the other one is list items. It's too generic. Now, I guess so coming from the relational database side, so if I try to do the same thing on a relational database, maybe I can store everything, but the performance will be horrible because my schema was too generic. So, but doing that stuff on MongoDB is performance an issue with two single, actually two collections for all the applications or all the devices. Would there be a performance hit?
No, I mean it handles up to like hundreds of gigabytes of data. I mean, you have to know how to shard it and scale it, but yeah, I mean, there's no performance issue with that. You need to make sure that all of your data is loaded in memory, because if you're writing to the disk, then you could get into trouble, especially if you're running on like an EC2 instance or something.
What do you think is the best practice to keep the data in one collection or break it into separate collections?
It's different for different apps. So it depends on how you want to design your client. Typically what we do is we recommend that people store the same object type in different collections and then access them that way. Dan?
Did you have any big surprises? Like things that you just came out of left field scale-wise that you didn't anticipate?
No, I don't think so. I mean, we've had, yeah, most of the time has been spent designing the API and making the libraries simple and easy to use.
So did you have to install any MongoDB APIs on the emulator or Android in this case?
No, this particular library is only using the REST API. So we built a REST layer on top of Mongo. Yep.
Are most of your users coming from the relational world and migrating their data over?
We do have a lot. Yeah, we're not saying that we're never going to support relational databases, but right now we don't. And out of the gate, we felt that this provided enough flexibility for developers to get going that it seems to work. So. We do oftentimes have questions about relational data, though. People want to know how they can map data between different collections. So it's really, the fundamentals are really not very different from just managing a foreign key, but you happen to do the merge on the client. Dan?
How do you handle document versioning?
We started out with CouchDB, which provides document versioning just out of the gate. We haven't had the need to track versioning for the features that we're providing so far, so we don't really need to deal with that right now. But it's something I'd be interested in talking about. So,
why did you switch from Couch to Mongo?
So it's a long story, but we felt that we liked Mongo's query language better than Couch's. Couch is lagging behind on the query side, so they don't provide as much flexibility there. If you actually look at our REST API, lots of Mongo language will kind of come out in that. We liked that Mongo based everything off of JSON, and the query language is in JSON, the object structure is in JSON. It's just makes it simple. So instead of building that on top of Couch, Couch provides the ability to do querying, but you have to build a map reduce function behind the scenes to actually expose queries. We felt that was too complicated for our users.
Do you allow ad hoc queries from the client, or is it more canned queries that are well indexed?
No, ad hoc queries are allowed. Yeah, as long as you have an attribute on a document somewhere in that collection, you can query for it.
You can query for non-indexed fields.
We have some magic behind the scenes that will index fields based on usage. So this is precisely why I think that people should really look at backend as a service for building an application, if you're building a mobile app or a web application, because we're going to cut out a lot of headache and save a lot of time for people who just want to build apps and stay focused on the use cases. Instead of hiring a new guy or two guys to handle your database.
Do you have plans in the future to provide something in the client libraries that allows for any synchronous updates to the cloud? So when the device is not connected, you could still be storing data?
Yes, very soon we have that ability. So right now we're testing different methods for synchronous data. We have beta versions of our libraries that are caching data, but then we're looking to try and solve the harder problem of syncing the data seamlessly so the developer doesn't have to deal with that. He just selects different strategies for the syncing mechanism. Okay. Are those all the questions, or? Great, thanks guys.